Space exploration should be more science than fiction. Argument by Claudia Alarcon. Background. Exploring the outer reaches of our solar system and sending humans to Mars is no longer the stuff of science fiction. NASA has sent orbiters and rovers to the Red Planet for decades. But now, the goal is to send humans to orbit Mars by the 2030s. Many scientists and politicians are rallying around this goal, as well as around other missions that will allow humans to probe the mysteries of space. What is out there? Are we alone in the universe? Are there inhabitable planets in our galaxy and beyond? For decades, science fiction novels, movies, and TV shows fired our curiosity. After the real life Apollo 11's moon mission in 1969, enthusiasm for new discoveries soared. Now, well into the 21st century, we must face the fact that these same questions are still unanswered. With so much human investment made, we must go forward, fully embracing space exploration as an important priority. Our future in space depends on science. Space exploration in the 1960s was fueled by the Cold War space race between the United States and Russia. The 21st century has brought a universal spirit of collaboration among scientists from around the globe. An excellent example is the International Space Station. This orbiting laboratory and construction site combines the scientific expertise of 16 nations. It allows for a permanent human outpost in space. The hope is that the station can serve as a launching platform for further space exploration. But space travel is not without risk. NASA's Space Shuttle program, which was the main connection to the International Space Station, suffered two terrible losses. After the explosions of the Challenger in 1986 and Columbia in 2003, the program was shut down in 2011. Recent presidential administrations supported putting priority on the commercial space flight industry. A program was put into place to help private companies pursue work on human spaceflight. There are dozens of private companies in the industry known informally as New Space. These companies have set their sights on what seem to be impossible goals. These range from tourist trips to the moon to the colonization of Mars. Space travel has its documented dangers, however. Direct human involvement aided by technological innovation could likely boost the potential for discovery. Technological innovations are developing to allow us to venture even farther into space. Such advances are opening windows into worlds we previously could not have imagined. Robotic spacecraft have conducted some of NASA's most exciting and productive missions. A prominent example is the Hubble Space Telescope, which has made more than 1.3 million observations since its mission began in 1990. It has traveled more than 4 billion miles, sending back stunning photos of faraway stars and galaxies. NASA has also conducted robotic missions within our solar system. The Cassini's mission to Saturn was one of the most ambitious efforts in planetary space exploration. This robotic spacecraft carried the Huygens probe, which parachuted to the surface of Titan, Saturn's largest moon. The Juno spacecraft orbited around Jupiter, sending observations that can help scientists understand the beginnings of the solar system. The New Horizons spacecraft flew by Pluto in 2015 after an almost 10-year flight. According to the National Academy of Sciences, the exploration of Pluto and the Kuiper Belt is the highest priority for solar system exploration. The asteroids in the Kuiper Belt offer a great opportunity for mining. Space mining represents an important step for finding resources necessary for interstellar travel and exploration. In addition, icy asteroids may provide a cost effective solution to space travel. Space entrepreneurs are looking into using hydrogen and oxygen from asteroid ice to manufacture rocket fuel. This space made fuel can be used to launch expeditions farther out into space at considerably less cost. Our moon contains helium 3, an element that could be useful on Earth for energy developments such as nuclear fusion research. Mining there can also yield rare earth metals, REMs, that are used in electronics and in the construction of solar panels. This form of mining, therefore, would be incredibly beneficial for our survival and advancement. In recent years, geological surveys have indicated the presence of water on the moon, which can serve to sustain a human inhabited lunar base. Scientists are also looking toward Mars as a potential new home for humankind. New discoveries keep emerging that raise more questions. It is imperative that we use all our available resources to continue research on Mars. Early missions to Mars, such as Mars Odyssey, were designed to make discoveries under the theme of follow the water. These missions showed the possibility of liquid water below the surface of Mars. With the Curiosity rover, the Mars exploration program is following a next step strategy known as Seek Signs of Life. This exploration phase aims to discover the possibilities for past or present life on the red planet. Curiosity is seeking evidence of organic materials, the chemical building blocks of life. Future Mars missions would likely be designed to search for life itself in places identified as potential past or present habitats. With all these advances and technologies in place and in development, will we see a human colony on the moon or on Mars in our lifetime? The best case scenario will involve a partnership between NASA and international space travel companies. Some new space pioneers have tested supersonic retropropulsion technology, landing rocket boosters on floating platforms and on land. This technique could be important for future Mars landings. NASA's rovers, weighing up to a ton, have successfully landed on Mars. However, they have dropped to the planet's surface in airbags using rockets and with the assistance of cables extended from a sky crane. A human mission would weigh much more, making landing more problematic. The previous solutions would not work for spacecraft carrying humans. On the other hand, the future of the human race and Earth itself is at stake. We are close to surpassing our planet's carrying capacity and exhausting our natural resources. Yet scientists and space entrepreneurs remain hopeful. Private companies seeking to colonize Mars believe the risk of spaceflight is similar to that of climbing Mount Everest. As we all know, this is risky but not impossible proposition. The final frontier is a vast and dangerous place, difficult and expensive to explore, but it offers infinite possibilities for expanding our scientific knowledge of our planet and its origins. Exploring outer space can yield new sources for precious natural resources and perhaps even find a home for future generations. We live in times where space travel and exploration should be more science than fiction. Let's keep pursuing the compelling questions that have driven us to these times. Space exploration may very well hold the key to humanity's future.